Welcome to the chemistry class. Today I will continue your organic chemistry chapter, and today I will start from the structural isomers of arenes. Okay, last day we have discussed about aromaticity. So today we will discuss structural isomers of arenes. Okay, so first of all, when benzene ring containing only one substituent, okay, suppose this is one halogen, X is a halogen atom, so only one compound is possible. Only one compound is possible. That means only one compound. Okay, one isomer. Now somebody will tell that we can write here also X. We can write here also X. We can write here also X. But all are equivalent. All are same. If you rotate, okay, if you imagine one axis here, okay, through this point, and if you rotate the molecule, all will be the same. So all are equivalent. So they are only one structure. Okay, these are only one structure in case of single substituent. But if there is double substituent, like this, so there is possibility of formation of three isomer. Okay, and and the substituents are identical here. Okay, so there is possibility of three isomer. Otherwise, you can write the different substituent also. This one is A, this one is B. Also, three isomer is possible. One is 1,2 position. This one is called ortho isomer. One is 1,3 position. One 3 isomer. This one is 1,2 isomer. This one is called ortho isomer. 1,3 isomer. This one is called meta isomer. And this one is 1,4 isomer. And this is called para isomer. Hope you can understand. Now, if there is three substituents, okay, and if all substituents are identical, then how many isomers are possible? Okay, so if there are three substituents, suppose here is 1x, here is 1x, here is 1x. So this is one isomer, and another isomer we can write. This one will be the another isomer, and one more isomer is possible, like this one. Okay, so in case of three identical substituent, there will be also three isomer. But if the substituent, okay, two are identical and third one is the different, okay, suppose this one 2 is X and another is Y. So in this case, total isomer will be the 6 isomer. 6 isomer. If the all substituents are different, that means X, Y, Z is there. So then there are 10 isomers are possible. X, Y, and Z. Then total isomer will be 10. Okay. If you draw, okay, then you will get here 10 isomer. If two substituents same, another is different, 6 isomer, and 3 are same, then we will got only 3 isomer. Okay. Next we will discuss that benzene. Actually in our syllabus there is benzene. So first we will discuss the laboratory preparation of benzene. So laboratory preparation of benzene is done. Laboratory preparation we have to take the sodium salt of benzoic acid, CAANA. Then if we heat with soda lime, NaOH and CaO, and apply heat, then there will be formation of benzene and sodium carbonate. Okay. So there will be decarboxylation. Carbon dioxide will be removed, okay, by heating with soda lime, and you will get the benzene. So this is one procedure. Next we will discuss the physical properties. Benzene is a colorless liquid, okay, with characteristics order, and its boiling point will be near about boiling point 353 Kelvin. Okay. Next, benzene is non-polar. Okay. Here all carbon hydrogen bond moment will be cancel each other. So we know that carbon is more electronegative than hydrogen, so bond moment will be towards here, and this one will cancel here, this one will cancel each other, and here also this one will cancel each other. So finally the dipole moment of this molecule will be 0, and that is why benzene is non-polar, and it is generally insoluble in water because water has dielectric constant, polar compound, okay, and it will be lighter than water also. If you take benzene liquid, and it will float on water because it is lighter than water, and generally it will be soluble. Generally it will be soluble in the organic solvents. Organic solvents means you can think about the alcohol, ether, okay, in this type of chloroform, okay, benzene will be soluble. So these are the physical properties. And another thing that we can tell, that the benzene can be used as a good solvent, okay, and many things you can dissolve like sulfur, iodine, and large number of organic compounds, okay. Sometimes we are crystallizing from benzene also, okay. Now its vapor is highly toxic, and benzene, you have to know that benzene is carcinogenic, but when we are putting one methyl group, toluene is not carcinogenic, okay, but benzene is carcinogenic, so it is very much toxic. And if you burn benzene, okay, and it will burn with a non-luminous sooty flame, as your percentage of carbon is high, so it will burn with a sooty flame, okay, and that we can tell that in contrast to the aliphatic unsaturated hydrocarbons, okay, which will burn with a bluish flame, but benzene burns with a yellow sooty flame. Next we will discuss the chemical properties. Now what will be the chemical properties? Actually we know that aromatic compounds generally do not undergo addition type of reaction, okay, because of this delocalization of the pi electron, and special character is there, that is called aromatic character, and due to the presence of the relocalized pi electron is very much stable, and it will not show addition like bromine addition or like KMNO4 addition, it will not respond. But in presence of light, okay, there will be halogenation, okay. If we take benzene ring and chlorine will be added in presence of light, there will be formation of hexachlorobenzene, and this is also called indene or gamaxine. The lindene, LINDANE, the benzene hexachloride, BHC. Okay, and we know that this is generally insecticide, okay, it can be used as insecticides. Next we will discuss that hydrogenation reaction. Hydrogenation, that means if you take benzene and if you add hydrogen in presence of nickel, definitely there will be formation of cyclohexane, okay. So from aromatic compound, it will forming the triple bond is there, and it will forming the saturated compound, okay. Now here in place of nickel we can also use platinum or rhodium like this okay, metals. Next we will discuss that ozonolysis. Okay, benzene will react with ozone as three double bond is there, so it will also form ozonite. So first we can write in this way. Then if you add zinc water, then there will be cleavage like this, and finally you will get the glycol, okay, that is CHO, okay. This is aldehyde, okay, CHO. And there will be formation of hydrogen peroxide thrice, plus there will be only hydrogen peroxide is formed. So here we are observing that benzene is giving that ozonolysis. These ozone molecules will react with this that double bond. Okay, 3 double bond is there, that is 3 ozone molecules required, and you will get benzene ozonite. Finally, by hydrolysis with zinc and water, you are getting this type of compound. Okay. Next, we will discuss that electrophilic substitution reaction. Benzene will undergo electrophilic substitution reactions. First, we will discuss that halogenation. So if you heat benzene with iron or ferric chloride and halogen like chlorine FeCl3, then there will be formation of chlorobenzene. Okay. So ferric chloride is a Lewis acid, is acting as a catalyst here. Actually, chlorine will react with ferric chloride and forming that electrophile that is required. Okay. We will discuss mechanism also in your syllabus. Here I will discuss the mechanism. So benzene will react with this halogen reacting with chlorine, and we are using FeCl3, or you can use only iron atom. Then there will be formation of chlorobenzene plus HCl. Or you can take that benzene and that is reacting with bromine forming FeBr3, or you can use iron. There also formation of bromobenzene plus formation of HBr. Now here mechanism is important. Mechanism. What is happening here? In the first step, that ferric chloride, Lewis acid, okay, will react with the Cl2, and there will be generation of electrophile. So first step is the generation of electrophile. So chlorine is reacting with FeCl3 forming FeCl4 minus plus Cl plus. Now in second step, what will happen? That electrophile will attack the benzene and forming sigma complex. Okay, so one carbocation will generate. Okay, that sigma complex formation. So benzene being is reacting with this Cl plus, is taking this electron rich center, electron deficient center. So we are getting this compound, and there will be some resonance. This positive charge is called sigma complex, is stabilized by resonance. Okay, and the third step is the elimination of proton. Elimination of proton. That here one H is there and positive charge is there. That FeCl4 minus will take the proton, and finally you will get the chlorobenzene, and there will be formation of FeCl3 and HCl. So in this way the product is formed. Okay, so first step again I am telling generation of electrophiles, second is the formation of carbon, that is called sigma complex, and third step is the elimination of proton. Finally you are getting back the aromaticity again, and you are getting chlorobenzene with formation of ferric chloride and HCl. In the same way bromine and FeBr3 will react, okay, but direct iodination is not possible, as well as fluorination also explosive, okay, not possible. And in case of iodination, that is reversible, and iodination can be carried out by some, in presence of some oxidizing agents like nitric acid or iodic acid, that is HiO3. When benzene will react with iodine forming Hi, that Hi we have to destroy by using this oxidizing agent like nitric acid and HiO3. So hope you can understand. So this is very important, halogenation of benzene ring. Next we will discuss the nitration of benzene ring. Nitration reaction. So benzene will react, okay, or we have to heat benzene with a mixture of concentrated nitric acid and concentrated sulfuric acid, 50-50%, okay, and this is also called as mixed acid. Sometimes in reaction condition we are written M.A. That means you have to understand this mixed acid. There is a concentrated sulfuric acid and concentrated nitric acid, and you have to heat the mixture around 60 degrees centigrade. Then you will get the nitric acid, nitrobenzene. So you are heating nitric acid concentrated, and you are also heating with the mixture concentrated sulfuric acid at 60 degrees centigrade. Then you will get that nitrobenzene. Plus there will be formation of H2O. Okay. Now in this case the mechanism is also very important. Actually, first will be the formation of the electrophile. Okay. So generation of electrophile or formation of electrophile. The first one is the sulfuric acid. Sulfuric acid will dissociate. H double bond S O OH, that will dissociate to H plus HSO4 minus. Then in the second step what will happen, that HSO4 minus, this proton will be accepted by the nitric acid. So HNO3 will accept, this lone pair will accept this proton and forming OH2 plus N double bond O, and then there will be elimination of water forming H2O plus N double bond O plus. So this is our target, that is the electrophile NO2 plus. So this N2 plus in the second step that will react with this benzene ring. Okay. Now I am rubbing this part. Now benzene ring in the second step is the formation of carbocation, formation of sigma complex. So this benzene ring is reacting with this electrophile forming sigma complex, and it will be stabilized by resonance. Okay, then finally third step, that is the elimination of proton. Okay, so elimination of proton, here one proton is there, and here that HSO4 minus is there. So this HSO4 minus will attract this proton, and there will be formation of nitrobenzene, and this will convert to H2SO4. So in this way we can prepare nitrobenzene very easily from benzene ring. Okay, by heating the mixed acid, that means concentrated nitric acid and concentrated sulfuric acid 20%. Okay, at the temperature we have to use, that is around 60 degree. Okay. Next we will discuss the sulfonation reaction. Sulfonation. Now in sulfonation reaction, we have to heat benzene with concentrated sulfuric acid, or we can use the fuming sulfuric acid, and temperature you have to maintain around 453 Kelvin, and we will get the benzene sulfuric acid, and this is a reversible reaction. Okay, so benzene is reacting with concentrated sulfuric acid. Okay, temperature we are using around 453 Kelvin, and you will get the benzene sulfonic acid, plus there will be the formation of H2. Okay. Now here also mechanism is very important. Okay. So first we have to think about the generation of electrophile. Generation of electrophile. First one, sulfuric acid will dissociate into H plus HSO4 minus. Then another sulfuric acid will be protonated. This will be protonated. Okay, and you will get plus, then there will be formation of sulfur trioxide, and this sulfur trioxide is our desired electrophile. Okay, in the second step, what will happen? In the second step, this benzene ring will react with this electrophile, forming the sigma complex or carbocation formation. So benzene ring will react with this sulfur trioxide molecule, forming this one. Here will be the plus charge. In the same way, the sigma complex will be stabilized by resonance. Okay, SO3 minus okay, and the last step is the elimination of proton, elimination step. Okay, now these are one thing I forget to tell, that these are all reversal reactions. Okay, so all are reversal step. Okay, next the last step is the elimination of proton. Okay, that is the first step. Okay, that HSO4 minus will come, that will abstract this proton, and you will get this sulfonate benzene sulfonate anion. Okay, so this is the first step. This is also reversible, and in the last step this will be protonated from HCO. So protonation is done. Protonation is done when you are adding HCO, SO3 minus H3O, then there will be formation of benzene sulfonic acid plus water. So in this way we can prepare the benzene sulfonic acid. Next we will discuss one more important reaction, that is called Friedel-Crafts alkylation. Friedel-Crafts alkylation reaction. So in this case we have to heat the benzene ring in presence of one Lewis acid, that is AlCl3, anhydrous AlCl3, and the reagent that will form that electrophile, that is the, we have to take that alkyl halide. Generally we will take methyl iodide, methyl bromide, or methyl chloride. So, and the hydrogen of the ring will be replaced by this alkyl group. Okay, suppose if you want to insert one methyl group, you have to take methyl chloride, benzene, and anhydrous AlCl3. If you want to insert ethyl group, then you have to take that benzene, ethyl chloride, and anhydrous AlCl3. Okay. So CH3Cl, we are adding anhydrous AlCl3. Okay. So then we'll add this methyl, and this is known as Friedel-Crafts alkylation. Now what will be the mechanism here? All mechanisms are same time. First there will be generation of electrophile. So methyl chloride will react with AlCl3, anhydrous AlCl3, forming CH3 plus AlCl4 minus. So this CH3 plus will react with the benzene ring, forming that is the sigma complex formation. Okay, so methyl will be here, the positive charge will be stabilized by resonance. The next step, we have to remove this proton. Okay. So next step is the elimination of proton. So this methyl plus and one proton is there. So we are taking that AlCl4 minus, is abstracting the proton, and we are getting our desired product, this toluene. okay, and there will be formation of AlCl3 plus HCl. So this is the mechanism of Friedel-Crafts alkylation, okay. Only the groups, okay, if benzene is attached with some electron withdrawing group, okay, like nitro group, okay, then it will not respond to this Friedel-Crafts alkylation. Another thing you have to know that if you want to prepare that propyl benzene, this method will not act, because here when you take that propyl chloride and AlCl3, there will be rearrangement of carbocation from 1 degree to 2nd degree, and you will get isopropyl benzene, okay. So that we will discuss later, okay. Next we will discuss another type of reaction, and that reaction is called that Friedel-Crafts acylation, okay. Friedel-Crafts acylation. So here we can insert one acyl group by this reaction. Here also the same reagent we have to use. Suppose if you want to insert acyl group as CH3CO group to the benzene ring, then you have to take that acetyl chloride and anhydrous AlCl3, then there will be formation of acetophenone. So benzene is reacting with acetyl chloride, and here we are using anhydrous AlCl3 forming COCH3. This is called acetophenone. Okay, if you take benzene and benzoyl chloride and anhydrous AlCl3, and there will be formation of benzophenone. Two benzene, okay. So this is benzophenone. Now what will be the mechanism of this type of reaction? Here also same type of things, okay. That this acetyl chloride will react with this AlCl3 anhydrous forming CH3CO plus AlCl4 minus. In the same way, this benzene will attach with this that electrophile, and there will be formation of sigma complexes. And again this will be stabilized by resonance. The same way. Now we are not drawing, okay. And finally there will be the elimination of proton. And this one is AlCl4 minus, will extract this proton, and you will get the acetophenone and formation of HCl. So in this way you can also prepare the acetophenone, and the mechanism is almost all over the same, like nitration, halogenation, sulfonation, Friedel-Crafts acylation, alkylation, all are same, okay. First step will be the generation of electrophile, second step that is the formation of carbocation, that is sigma complex, and third step there will be elimination of proton, okay. Next we will discuss that the oxidation in presence of vanadium pentoxide. If you take benzene ring and in presence of vanadium pentoxide, okay, at the temperature it will react around 775 Kelvin, that will produce malic acid and malic anhydride. And another very important reaction is there, that is called pyrolysis. When vapors of benzene is passed through the red hot copper tube, okay, packed with the pumice, okay, and the temperature you have to maintain around 900 to 1000 Kelvin, then there will be formation of biphenyl. Okay, so that means benzene vapor you are passing through this red hot copper tube, then there will be formation of biphenyl. Okay, now in this way we have completed the chemical properties of benzene, and next day we will discuss the other type of substitution reaction. Suppose already a group is present in a benzene ring, suppose a methyl group is present and you are doing the nitration, then in which place, okay, we have already discussed about the isomers. Okay, so there are when there is two different substituent in the benzene ring, then there will be formation of three type of different isomer orthoparameter. So whether in toluene when you are doing nitration, whether there will be formation of the meta isomer or orthoisomer or para-isomer, which one will be major and which one will be minor, and why ortho or para is major, okay, and meta is minor. And sometimes if we introduce some electron withdrawing group like benzoic acid, if we do the nitration in benzoic acid, then whether the orthopara will be the major or the meta will be major, that we will discuss in the next day. So today up to this, thank you.